Welcome back, guys. I've had a lot of requests to talk about parting blades and parting operations in the lathe. It seems to be a difficulty that many people find whenever they're on the lathe and they're trying to use parting tools to part pieces off or cut grooves. And seems to be a lot of confusion out there on the proper principles and operations to properly use the parting tool. What to do, what not to do, and how to correct problems such as chatter. So what I want to talk about today is the two different types of parting tools that I have and that I use. The two common type that most everybody have, really. You know, you have a high-speed blade, and then you have blades that take carbide inserts that are pretty common. And I'm often asked also, which is the best to use? I think they're both great to have in the shop. They both have a purpose, and they both serve a good purpose around here. There are some materials that's going to be better suited to use a high-speed blade on, and then there's other materials that's going to be better suited for a carbide tip, a carbide insert tool, or even a carbide tip blade. So an example of that is anytime you're doing something like brass or bronze or aluminum, some soft material like that, a high-speed blade works great. All right, whenever you're doing operations where you want more speed, or you're doing, say, steel and, you know, high-grade steels, tougher material, stainless steel, things like that, sometimes a carbide insert parting tool is better suited for that. Not always, but most of the time it is. You know, even like stainless steel. Sometimes I've had applications where stainless operations is better suited with a sharp, high-speed tool at low speed with a lot of cutting oil. Does a better job. The problem with this type of tool right here, this insert, it creates a lot of tool pressure against your workpiece. Lots of tool pressure there. You don't have so much tool pressure with a high-speed blade. Okay, so you're more prone to chatter with this carbide than you are with the high speed. So let's talk real quick about the two different types. So if you're trying to, you know, build you a collection of tooling and you want to know what's best, I would say start with high speed. If you don't have anything, start with a high speed blade. Tools are pretty easy to come by. There's a lot of inexpensive imported options to hold parting blades. Now this is just an example. I don't use this, but this is an old, was that an Armstrong parting tool holder? You can find these all day long on eBay, you know, but these hold your parting tools. So you can get you something like this to hold a tool if you don't have a dedicated tool block. There are blocks like this that you can buy. This is like one of those, you know, import ones that holds different size blades. These are all different sizes, and I'm not here to talk about all of the different types of blades or sizes and the nomenclature on the inserts. We're just gonna discuss carbide tip versus high speed and some parting operations in the lathe. This block right here, I believe I found that at the flea market. This is a homemade blade holder. So this is a good project for anybody, you know, looking for something in their home shop. If you don't want to buy one, you want a good project, you could build something like this right here. It's just an exact copy, you know, of a name brand tool block, except this one is adjustable, and you can use different height blades in this right here. All right, so I haven't even used that, but I've got some different blades. So the benefit of this homemade block is that you can make you something like that, and then you can use different size blades like this here. All right. So on my tool holder, I use the multi-fix style, and the factory uses this type of parting blade for their holder. It's a dovetail type, so you have an angle on the top and the bottom of the blade, and then this block right here slides as you tighten these top clamps here, these top bolts. as you snug those, it's pushing down on that block and wedges it in there on the dovetail. A very rigid, very effective style of holding that. Okay. So you can grind these high-speed blades. You put you a nice grind on there with a little bit of a back rake or a chip breaker on the end. You can grind it sharp, hone the edges right there, and you can get some very nice positive cutting action out of a high-speed blade like that. And again, that works really good on softer materials. Anytime I'm doing brass, bronze, something soft like that, I'm always going to use a high-speed blade for that. I just get a lot better chipping action, better chip control. On these type of inserts like that, you have a lot of spray on that. Those chips are just going to be flying at you. You got to set you up a little guard there to block all the chips. And again, you're creating more tool pressure there. This is just an example of some more high-speed blades. Empire is a very common brand. You can find these on eBay, and they come in a various different widths and different heights. Here's another one right there that's a little bit more narrow on the height, and it's also carbide tip. So if you ever need to part through something tough or hard, or even say like cast iron, just something that you need a little bit tougher cutting tool, you can have you one or two of these around, the carbide tip, and that'll help you out there as well. I can also use these Empire blades, even though this is like the T style. You can still put this in this tool holder and use it. I use that on some of them, like this one right here. You see I've got a radius ground on the end of the tool, so you don't always have to have a square tool bit. You can just use a parting tool, and this is great for thread release or radiuses in the corners of your shafts. Anything like that, you can just grind that up and have any kind of angle on the end of it you want. So that is the two main styles that I use. I also have this guy right here. This is a Sandvik Coral Cut. I don't remember the type of insert this is, but this is a very good quality cutting tool right there. And I like this one better than the self grip style here. This seems to have a better cutting action. This is a more neutral rake, but it has a sharp feel to the edge of the insert. It's almost a real sharp feel, so you don't have quite as much tool pressure, and the geometry of the insert just pulls off a nice chip using this right here. So you'll oftentimes see me using this one. I've had it in several videos, and it does work really good. These are just kind of considered stick tools in the tool making world. Instead of being a blade, it's just a whole tool itself. All right, so I think that's going to be about enough with the types of blades. Just remember, get yourself a high-speed blade, get you a couple of them. These are pretty cheap to acquire, and get you some grinds. Have you a nice sharp grind on there. Just make sure you have the right relief angle underneath so that you're not rubbing. A lot of times I like to grind a lead angle. Let me see if I can get that where it's leaning either to that side or that side. If you're going to part something off, you can have you a slight angle like this so that the little nub that's still on your piece whenever you cut it off, it stays on the material. All right, so I got a couple pieces of material. We got this bronze. We'll do a little test cut on that. And I got this piece of DOM tubing, it's steel, and we'll go over there and we'll use two different types of tools and make some cuts. And I'll talk about proper speeds to set up at and what to do whenever you're getting chatter and things like that. So before we start making any cuts, let's talk about a couple things that you need to make sure you do first on your tool. First thing that we're going to start with is the tool stick out. Now I like to use the general rule of thumb of whatever the height of the blade is. Just say this is a 1-inch blade. 1-inch stick out should be about your max. Now you can go beyond that, but don't do it on a regular basis. If you're just doing normal parting or grooving, keep the tool pushed back into the tool holder as far back as you can and get away with what parting needs you have there. So don't get in the habit of sticking the blade way out there. I see people do that all the time, and it's not good practice to leave your blade hanging way out of the tool. So keep it pushed back in. The other thing that you want to do is make sure your tool is square to the work. There's a couple quick ways you can do that. You can run it up over here and square it up on the side of your chuck. You can square it up on your workpiece with a machinist square, or do like I do. I set up an indicator right here and I run it back and forth and I indicate my tool post square. And that's how I keep all of mine, and that is for grooving operations, threading operations, and parting operations, so that my tool is perfectly square. It's not kicked off at 1 or 2 degrees. It's perfectly square. All right, and then the next thing that we need to do is make sure our tool tip is on center. So the way that we're going to do that today, we're going to use the Pro lathe gauge from Edge Technology. It's this guy right here, and this is really convenient if you're using a 3-jaw chuck or a self-centering chuck or a collet chuck, something like that. It's got this bar that runs through there. It's on ball bearings, and you chuck it up and you set the tip right there and use that to level out and make sure that your tool is on center. You need to make sure that it's calibrated before you use it though. Whenever you get it, they're not calibrated. So this bottom edge right here is machined square. So what you want to do is just set it on a flat part of your machine, such as the bedway right there, or over here. I know you can't see that, but so just square up your level and get it calibrated first and tighten the bolt up. And we'll go ahead and come over here to our chuck and chuck it. All right, just tuck it lightly. And we're going to run our tool bit up there. And just rest it right on the tip of your tool. And we got that thing square, but we're going to go ahead and move it so that you can see. We'll loosen it up and we'll drop it down. So that's what it would look like if it's low. So once you set it on there, adjust your tool height so that you're on center. You got to snug up your tool post a little, because sometimes that moves. All right, that looks pretty good right there. We'll go ahead and lock the lock nut. Okay, so we're going to do it with that one. And while we're at it, let's go ahead and we will check our carbide insert as well using this tool. Get it right on the tip there. So it looks like it's just a shade high. Okay. All right. Pro lathe gauge. That makes it pretty convenient. You can check all your tools at one time and go through all of them and get them set to the height and lock these things in. So we'll start with our bronze workpiece and our high-speed tool, and we'll compare the two using a high-speed blade versus a carbide tip blade. This is the preferred tool for me, what I like to use on bronze. I'm going to run this thing at 180 RPM, and I'm just going to hand feed it. I'm not using automatic feed here. So I've got a little bit of back rake on that edge of that tool ground into it. And it's nice and easy. There's not a lot of tool pressure there, and we have nice chip control there. The chips are not popping way off. They're not hitting me in the face, and most of them are just dropping straight down into the lathe there. We can kick it up. Let's see what it does. We'll go to 370. So even at 370 with a controlled hand feed here, we've got really good chip control, and there's not a lot of tool pressure there. You come in there very lightly once you start making that line, and with that angled tool ground on there, you should be able to pop your workpiece off. Alright, and it usually leaves the nub there, but what the problem is here, that's that casted bore. It's not machined, so that's what was giving me a problem right there. Alright, there you go. Alright, so let's try that again with this carbide insert tool and let's see what happens. Same speed, that's 370. Alright, now they're slinging back at me. That is let me show you. You see that? There's no need in all that. But you can slow it down and it'll improve it some. I would just suggest on this bronze like this, use a high-speed tool. Right there, there's a lot of tool pressure I'm having to feed in to cut that piece. It's making a big mess back here on me. Let's go ahead and finish it out. See what it does as it parts it off. Alright, see, the nub part popped off with the piece that I wanted to save. Now, one of the benefits of the carbide, a lot of times you'll have a really good surface finish on this area here where you parted off on, you know, your workpiece. A lot of times on your high-speed tool bits, your hand ground ones, you don't have a really nice looking finish. So that is one of the benefits of the carbide, is that you can get a better finish there. We're going to go ahead and move on to the steel. This is a little bit tougher, and I think what gives a lot of people more of the problems that they encounter. So let's run it at 180. So one of the problems that people have is chatter. And usually my fix for chatter is always slowing it down. If you're running a little bit too high RPM, it just seems to want to bounce a little bit off of it. So if you run into some chatter, drop your RPMs, use a heavier feed rate, and then a lot of times it'll get up underneath that chatter and it'll go away. And let's see what happens right here. Also, when you're using high speed, that thing likes oil. It needs lubrication. If you don't, it likes to weld, you know, chip weld as you're cutting it, so you need to keep it lubricated. I've got both the brush style and I got the oiler here. A lot of times I like to use the pistol grip whenever I'm doing some parting. Alright, keep a heavy feed rate in there and keep it wet. If you don't use the oil, I can hear it and I can feel it on the crossfeed handle trying to stick. You put a little oil and it just smooths out. Alright, so that's doing pretty good for me right there. If I was to kick that thing up, it's gonna liable to burn the tool up. Alright, now you see that color? It's too hot. So it's running too fast. I was hoping that it would try to chatter on me, but this particular job, it's not doing it. Small. Sorry about that. I had to brake there. The battery went dead. So let's get back to finish parting this off. So we slowed it down because the speed was a little too high. And even though it's not chattering on me, if you was doing this piece right here and it was trying to chatter on you, I'd say slow it down a little bit. Keep it oiled. Every time I stick that brush in there, I can feel the tool just going in that steel even easier. Alright, so there's your finish with the high speed. You see there. We'll swap it out and do it with the carbide insert. Alright, so this particular lathe does not like those wide parting tools, so that one's a bit wider. I think that's around 155 thousandths wide or so. We'll see what it does. It's right on the verge, it feels like. And so you don't have to use cutting oil with that carbide, but if you do, it's just going to make cutting it smoother. Flood coolant would be the best option if you have it there. Let's see what it does when you run it faster. See the color of them chips? Just creating a little bit of heat. You can hear it trying to chatter. It's just right there on the edge. The way that carbide geometry is shaped is that it helps collapse that chip in on itself. And usually whenever it's straight like that, it leaves a nub on your workpiece. So, alright, we got some successful parting right there. I was trying to get some chatter in it and just wasn't getting it. It usually does it on a job that you're on. So just try to remember some of the tips that I pointed out. You know, your stick out, your lower speeds, and using your cutting oils. I think that's going to be about the end of this video. I hope that I touched on some of the questions that have been asked to me about the parting and the subject of parting. Just try to remember a few of the key points that I brought out. Was having your tool on center. Make sure that it's on center before you start your work, and also make sure that it's square to your work as well. You know, square it up against your workpiece or your chuck, a machinist square, or indicate your tool post, something like that. Always make sure that it's nice and square. Don't use too heavy of an RPM. If you experience some chatter, drop your RPMs down. Use some lubricant to help keep the chips from welding onto the tool as you're parting it off. If you're using an old lathe, like an old South Bend, a lot of the guys watching use the older lathes, like South Bend's flat belt driven, plain bearing machines. I would suggest stick to high speed tools in that case, unless you're using a very narrow carbide tool. High speed is going to be your friend for doing parting and grooving operations on those machines. Keep the tool wet with some oil or flood coolant if you got it. Oil is a little bit more slick. It'll help keep a little bit better cutting action. Of course, your coolant is going to keep your tool and your workpiece very cool, so I'd always recommend that if you got it. And again, we can see a couple of the differences in carbide versus high speed. Now, you can get these inserts in right and left hand offset to eliminate stuff like this. I don't have any myself, but that's one of the benefits of having a high speed tool, is that you can grind that thing so that whenever you part it off, you're not leaving the the little nip on there like that. So hopefully that helped answer a couple of the questions, and drop me a comment, let me know what you think. I know that we didn't discuss everything that has to do with parting, but hopefully this helped you out a little bit. If you got any questions or comments about something else that we can talk about here in the shop, leave me a comment, and I always go through and read them all. And hopefully enjoyed. We'll see you soon, okay?